Um, you know, some of us, like myself, we kind of go back there and touch things just without any kind of grounding protection. So we want to make sure our products have some kind of protection on them. So this is what this gun is for. We have a couple of modes that we test. We have operationally and non-operationally. From an operational point, we go up to about 10,000 volts around the button area, and then we'll go up to about 15,000 volts all around the chassis, and then in the non-operational mode, we'll go up to about 20,000 volts, going at about every 2,000 volts, checking to see if it turns on and nothing happens to it. So I'll give a little demo here. This is about 10,000 volts. Would you guys like the lights off, or want to see if
Yeah, lights off.
Could somebody turn the lights off, please? Maybe, hopefully you can see the,
Don't touch.
can you guys see that?
Yeah.
Let me raise it a little bit. Hopefully nothing happens to the notebook. So this is about 15,000 volts. Did you guys see that? So usually we've got some diagnostics running at the same time. We want to make sure nothing happens if there's any kind of data calculation. So you know, we've got that diagnostics, but you know, once we do the zap, then we'll move the mouse or touch some keys, making sure everything is still functional. Any questions? You guys need more pictures?
Yeah.
Should I
Do you check
zap
the
it some
data
more?
on the hard drive?
We've got an issue. It could be maybe, for example, on the I/O ports, maybe there's no protection. For example, a diode going from the port to the controller. So we want to make sure that's in there as well, and it's the right type of diode. Sometimes there might be a tolerance in the back too, where the discharge is going somewhere else and not where it's supposed to. So we're checking for those kind of tolerances or gaps that may affect that ESD discharge. So as you can see, this is a robot room. Anything mechanical that we develop that's new mechanism, new plastic, for example, the new drive that we get, we're putting it through some kind of a test. We've got standard tests that we put them under. It'll go through about thousands of cycles, and it'll take about 2 or 3 days to complete the testing. Also have customized testing. If there's something new that's out there, we have to do a special test on it. We'll fix something up and try and run some tests to make sure that whatever we're concerned with, everything is working up to standard. So in this case, we've got an optical drive and a desktop. We're making sure that the push button is working okay, making sure the mechanism to push that tray out, also the mechanism to bring it back in is all working okay. We'll test it, or we'll even put like a CD or DVD in there to run it, making sure it's working to begin with, and then after so many cycles or at the end, we'll put that disc back in there, just making sure that it still works and everything's working the way it's supposed to. Any questions on this one here?
How many cycles did you say?
I don't know the exact number. It's over 5,000 cycles, I think.
Right.
Yeah, it could be. I mean, we get these from the mechanical design group, so whatever they give us, we'll put it for a test. So we want to make sure that design is working well before we put them onto our materials. So we'll qualify the hinges first up to over 25,000 cycles. Once we're okay with that design, then we'll tell our mechanical design team to give us the materials of the notebooks or desktops, whatever it might be, and we'll put it through this kind of a testing. So right now what we're checking is we're still checking for that hinge, making sure it's still working. Or maybe the screws inside, the screw holes, they're not properly designed to hold that screw, so it might get loose and therefore just come apart and cause some kind of a breakage on the material. Some other things that we test for are the wires or the cables that are going between the hinges or from the base to the panel. We want to make sure nothing happens to those wires, that they don't break in any way. or cringe or bend or whatever. So we're checking for all that kind of stuff. Even sometimes the panels themselves, we're making sure when they turn off, they come back on as well, and nothing happens to the electronics of that type of work.